So far we've mainly been working with right angle triangles, and we've been using two tools. That would be the Pythagorean theorem and trigonometric ratios. What if our triangle is not a right angle triangle? There are two laws that can help us find a missing side or angle, and that would be the sine law and the cosine law. But in this video, we will be focusing on only the sine law to find a missing angle or a missing side in a non-right angle triangle. The sine law states that in a triangle, the ratio comparing the length of a side to the sine of the angle that is opposite to that side is going to be equal for all sides and angles in that given triangle. It's important to label the triangle accordingly. Our lowercase letters are the lengths of the sides, and our uppercase letters are the angles. Let's actually use this in an example. So here we have a triangle, it is not a right angle triangle, and we're going to use the sine law. We need to label our triangle accordingly, but it does not matter whether you put A, B, and C in a different spot, as long as the side that is opposite of that angle is the same letter. Here's our sine law, and now we can start substituting in our information. So side length A we do not know, but we do know angle A, and that is 32 degrees. We do not know side length B, but I'm going to call it P because that's how it's labeled in our question. But we do not know angle B yet. And side length C is 21. Angle C is 95 degrees. Now what we need is a complete ratio, and we actually have that here. This is a complete ratio because we know the side length of C and the angle C. So we're going to use that to help us find our unknown side length P. So we're actually going to use these two ratios to help us find our unknown side. We only really need 2 of the 3, and since we have information missing for side length A, we're not going to use that. But there is a problem here. We have a complete ratio here, but we have no information right here for side length P and angle B. But can we find this angle? What do we know about the angles of a triangle? Well, if you recall, the interior angles of a triangle add up to 180. So if we take 180 and subtract the other two angles, we can find angle B. So angle B is actually 53 degrees. So we can fill in this information. We still don't know side length P, but we know angle B is 53 degrees. And we're using side length C, which is 21, and angle C, which is 95 degrees. To solve for P, we can do cross multiplication. So what happens is that sine 95 comes beside the P, there's going to be multiplied. And that sine 53 is going to be beside our 21, these two should be multiplied. But we're finding this side length P. So how would we isolate that? To isolate P, we're going to divide by the sine of 95. And what you do to one side, you gotta do the other side. And you can put this entire thing in your calculator. Just make sure you put brackets around your 21 multiplied by the sine 53, and then divide by the sine of 95. And once you do that, you should get that P is equal to 16.84 if we round to 2 decimal places. Here's another example, but I would like you to try it on your own. This time we're finding angle X. So make sure you label the triangle accordingly, label your angles and your sides, fill in your sine law, and then you want to isolate for this angle X. Okay, so pause the video, and then when you're ready, you can hit play to check your answer. Now if you've solved it, this is our answer. Some of you may have only gotten up to this point, but remember, we're finding angle X, so we need to isolate only the X. So don't forget, because we're finding the angle, you need to use the inverse of sine to find this angle, and our actual angle is 29 degrees. And here's another example. Two tracking stations are 20 kilometers apart. The measures of the angle of elevation of a rocket that was launched with a weather satellite. Both tracking stations are situated west of this rocket. So suppose the rocket is here, and we have our two stations that are west. So these two stations are west of this rocket. From station A, the angle of elevation to the rocket, so this angle right here is going to be 41 degrees. And from station B, it is 70 degrees. So remember, your angle of elevation is going to be from a horizontal line. And here is our rocket. And so this angle of elevation is 75 degrees. We're finding the altitude of the rocket. So we're finding pretty much the height of the rocket. This line right here. So how are we going to do this? Let's first start off by filling in some more information. So can we find this angle right here? We actually can, because if we do 180 minus 75 degrees, we will get this angle right here, which is 105 degrees. And that means we can complete that triangle and fill in this angle right here. If we do 180 degrees minus 105 degrees minus 41 degrees, we will get 34 degrees. Now if we look at this diagram, we actually have two triangles that are involved. We have this triangle right here, and then we have this triangle. That second triangle happens to be a right angle triangle, but we're looking at H. We're looking for this height in this right angle triangle. Since it is a right angle triangle, we can use Pythagorean theorem, but we don't know any of these side lengths. We know an angle, so we can use one of our trig ratios, but we need another side. So can we find one of these other sides? Yes, we can. We can actually use the sine law to find this side right here. So I want you to try to pause the video, use sine law to find this side right here. So if you solve for side length A, you get 23.46 kilometers. So in the second triangle, in this triangle right here, it is 23.46. Now since that is a right angle triangle, you can use one of your trigonometric ratios to find for height. Now you should have used the sine ratio to solve for height because the height is the opposite side and the 23.46 is the hypotenuse, and our altitude of the rocket came out to 22.66 kilometers.